All right, hi guys. Let's get started with working on logs today. We're going to rewrite logs, and whether we're going to use a calculator or not, some of these we'll be able to do by hand, and some of these we will need a calculator. That's why we're going to have to ask you guys to make sure you guys have your calculator near you today. Okay, today we're going to simplify logs. And the word simplify just means make it simpler, and then we're also going to evaluate them. Simplify logs and evaluating and evaluate. Okay, so we look at an easy problem that we talked about before, and the idea is, what do logs do? Logs solve for exponents. Meaning, if I say log base 10 of 100, what exponent would get me there? 10 to what exponent would be 100? Circle of logs. 10 squared is 100, and that's what you should get. If you guys have a calculator right now, we can always type this in a calculator being log of 100 over log of 10. Now, something that we should know already is that when you write log by itself, this is really a common log. It's always counting in base 10. So you'll see your calculator, and sometimes you'll see the word log. That's automatically counting in base 10. Natural log is counting in base E. And those are the two most common ones. Sometimes I see my Apple calculator, you'll see log base 2. That's fine, that's just, there's a 2 there. But if you don't see anything, it is always base 10. And if you see natural log, that's always base E. And these are the most popular ones we use. So if you just write log of 100, that will give you 2 because there's an invisible 10 there. Okay. But what if we don't have base 10? Let's take a look at another problem here. Oh, actually, okay, let's look at another problem here. What if I write log base 2 of 7? Now, can 2's multiply each other to get 7? If I say 2 squared, we know this is 4. And if we say 2 cubed, we know this is 8. So 7 is someplace between this number. So 2 to the x. So x is someplace between 2 and 3. So we would say it's 2 point something, right? 2 point something. Now, we have calculators nowadays, right? Compared to 30 years ago, where people would have to look this up in a logbook. And no joke, in my my pre-calc book, there was like 30 pages of logs, and you would have to look up these logs, okay, one by one, and it was a specific way of them categorizing each of these numbers. But these days, since you guys have calculators, you just have to type this on your calculator: log of 7 over log of 2. And we said this was called change of base. So if we have one single log, you can easily find that out by plugging into a calculator. Whether you can do it in your head, 10 to what power is 100, or you can just say log 7 divided by log 2, and this is going to give you something like 2 point something, because we know it's between 2 and 3. Let me go ahead and pull out a calculator. If I got one here, probably going to show me an ad. Here you are. Okay, we said log, where's my log? We can use log base 10 here. Okay, so on my calculator, we have to type the number first. So we're going to go 7 log divided by 2 log equals, and we get 2.807. Now, what does 2.807 mean? It means, well, log base 2 of 7 is 2.807 approximately. Now, this means 2 to the exponent of 2.807, that would give us approximately 7. That's the exponent we would need, 2 to the 2.8 power, to get close to 7. Now, this isn't a whole number. This is irrational number. It's going to go on forever. It's never going to repeat. Okay. So what if it's not in this nice format? What if the log isn't a nice, easy, just one piece number? And that's what we were talking about before. What if I wrote log base 3 of 5 minus log base 3 of, let's use 125. Okay, so each of these logs separately, we can't do it, right? Just not going to work for us. So you could type this out in your calculator, log base 3 of 5 minus log base 3 of 25. But I want to save you guys some time and remind you that when I'm subtracting logs here, we are dividing it. So sometimes it's a little easier for you guys to rewrite it. And in this case, I can simplify it. 5 does divide it into 125. Log base 3 of, oh, sorry, my bad. 1 over 25, because the 5s and the 125 divide out. And then I could type this into my calculator. Now, I want you guys to practice this real quick on your calculator to make sure you can get the right answer. If you have a nice $10 calculator, you can just type that in as you see it. Now, everyone needs to know how the calculator works, because if you go and take the SATs, there's no raise my hand, I don't know how to use my calculator, and you just waste time. So you want to make sure you know how your calculator works. So if your calculator doesn't work by just plugging it in the way you see it, some calculators have this really cool trait where it gives you empty boxes and you fill in those empty boxes. Fabulous. But if you don't have that calculator, we're going to have to do change of base. Log of 1 over 25 divided by log of 3. Okay. Now, I'm going to show you guys how I'm going to type this in my calculator. On my cheap calculator, I'm going to type 1 divided by 25 first, hit equals, and that'll give me one decimal number. Then that number, I'm going to log it. It's going to give me some crazy decimal number. But I'm not going to hold that. I'm going to keep that on the calculator. Now I'm going to write divide by 3, log this number, and then hit equals at the end. So I'm going to box all the keys that you're going to press. So again, if you take a look at it, it seems like a lot of a weird order here. I'm asking you guys to press this stuff in, but I'm just following the way the calculator works. I'm going to do 1 divided by 25 equals. Now we're going to log this button. Now again, it doesn't matter which log you use as long as you use the same, same log. Let's use log base 10. Hit divide by 3 log. Oh darn it, I hit the wrong log. If I mix the logs, it's not going to work. So let's go redo this. 1 divided by 25 equals, we're going to log this. Then divided by 3 log equals. Okay. I'm getting negative 2.92, rounding up 2.93. Okay, let me try that again. 1 divided by 25 equals, and we're going to log this, then divide this number by 3 log. Yep. Okay. Now, why is it negative? If you look at the answer, is log base 3 of 1 over 25. This would be negative 2.93. Now, if we think about why is it negative, circle of logs, 3 to the negative 2.93 power, that would give us 1 over 25. And the negative exponent would make that into a fraction. So 3 to the exponent, where's my exponent here? xy 2.93. That's going to give us really close to 25. And since it's a negative exponent, it's going to put it on the denominator. So sometimes we want to, again, rewrite these logs so it's 1 log so I can write this on my calculator. Okay. Now, here's another problem that looks like it could be a lot of work. So ln natural log of e to the 6 minus 1 over 2 natural log e to the 6. Okay. Now this problem is a little tricky. Now I would like to remind you a couple things. Is it whenever it's a fraction, it's not necessarily a negative. It's that if the fraction is, see how the bigger number is on the bottom, that's gonna lead you to a fraction, lead you to a negative exponent. If I wrote something like 3 over 2, that wouldn't be a negative exponent. But if it's like 2 over 3, because the number is bigger on the bottom, it's going to make the number smaller. That negative and exponent makes it smaller. Okay, now this problem is a little bit weird. And now I want to remind you of a rule for logs. Now, real quick before we get to it, here's the rule. The rule is log, if I remember, if it's the same base as the number, they cancel out, and that's just 1. Okay? Log base 10 of 10, right? What exponent of 10 gives you 10? Well, that's just 1. Log base crap of crap, right? Well, that's just 1 because crap to the 1 power is back to crap. The idea is this gives you 1. It cancels out. We can do this for this problem also. Except remember, this is natural log, and natural log is the same as log base e. So log base e of e, natural log of e, is the same as saying natural log or log of e of e. And this is just 1. Both these actually turned out to cancel out. So for this problem, it looks super confusing, but there's a couple tricks that we're going to do. First, what happens to exponents in logs? They get moved where? Logs bring down the gods. They're going to be brought down to the front. 6 ln e minus 6 divided by 3 is, no, 6 divided by 2 is 3, natural log e. And now we said natural log of e, those are just both 1. And 6 minus 3 is just 3. Okay, this problem, which looked totally crazy, and you can imagine them giving you this on an SAT or something of this type of derived weirdness, to remind you, hey, if I could get rid of some logs, let's do it. Now, if I rewrite this as log base 4 of 16 minus log base 3 of 27, right? Remember, log solve for exponents. So what exponent would this be? 4 to what power is 16? We can do that even without a calculator. That's going to be 2. 3 to what power is 27? 3. Okay, that's the exponent. If this wasn't as obvious, I'm going to rewrite this in a different way. Log of 16, isn't that just 4 squared? And isn't 27 just 3 cubed? Move this to the front. Move this to the front. 2 log base 4 of 4 minus 3 log base 3 of 3. And you can please notice that whenever you log the base and the answer, same thing. Remember, the exponent is just 1, so that's going to be 2 times 1 minus 3 times 1. So the problem, though it might look a little confusing when we first start, go back to our basic log rules and we can break that down. All right, so this is us dealing with logs now that we have logs. Now, we're going to use it on our next step. We're going to apply the rules that we just did here on problems that we need to solve for. Now, we've done this before again. If I say 27, no, let's not use 27. Let's use 2. 2 to the x power is equal to 5. Now, can you multiply 2 times 2 times 2 times 2 a bunch of times to become 5? No, we're stuck, right? Because again, we mentioned before, 2 squared is 4, and 2 cubed is 8. So, well, isn't 2 to the x kind of stuck in between? So it's going to be what? Okay. So x is stuck between 2 and 3. So x is 2 point something. Now, I'm going to help you right now find what that actual answer is. But we're going to, again, do it 2 methods. We did this a little bit before. Now, we're going to do it the identity way. If you have a nice log by itself, let's write it as a circle of logs. Log, what is the base? Is the base 2x or 5? The base is 2 because I'm multiplying by 2's. Log solve for exponents. X is the exponent. And the answer is 5. 2 to the x power is 5. Circle of logs. Now what you have here, you're ready to go to solve it. Log of 5 divided by log of 2. And you can type that on your calculator. 5 log divided by 2 log is 2.32 approximately. And this is what we said, it was going to be between 2 and 3. So we're able to now solve for what we could not do in Algebra 1. We're able to solve for exponents. In Algebra 1, you are not able to solve for exponents. Now I'm going to double check that. If I say circle of logs, 2 to the 2.32 power. Does that give me approximately 5? 2, let's get there, 2xy 2.32. We have 4.99. It's pretty darn close because of round off error. Now the second way to solve this is actually using logs. And what I mean is, I'm actually going to write logs to both sides. If you remember, if I give you a problem that says 3x plus 5 is equal to, let's use 11. In Algebra 1, if you do one thing to one side, you do the same thing to the other. That's only fair. And if you do one thing on one side, you do the same thing to the other. That's only fair, because they're equal. Right? We learned the skill from Algebra 1 is that if I do one thing to one side of the equal sign, I can do the same thing to the other, and that is fair. Now I'm going to teach you guys a new type of tool here, and again, we've seen this before. It's about using logs. If I say 2 to the x power is equal to 5, I need to somehow get this guy to the ground. You guys ever watch mixed martial arts? MMA fighting? One of the things that everyone does, the goal is to get that guy to the ground. Get them to the ground so you can beat the crap out of him. And that's what we're going to try to do here. Except we're not going to use mixed martial arts. We're going to use a stick. We're going to use a log. And we're going to break the kneecaps off both these sides. I'm going to use a log. Take a look. I'm going to use a log to both sides on my left side. And I'm going to use a log to, I'm going to take the baseball bat. I'm going to take the log and I'm going to hit it on the left, hit it on the right. Now, is this fair? Is this fair to do? And the answer for us is yes. I'm doing the same process to both sides here, and this is going to be okay. Now, we repeat, what do logs do to exponents? Remember how we said we needed to get that x as an exponent on the ground? Logs do that. It brings down the exponents to the front. X log of 2 is equal to log of 5. Now, our last step is we're going to move the log over through division. X is equal to log 5 over log 2. Now you guys have to practice this a couple times yourself to make sure it makes sense and it clicks. This process is something I'm going to repeat all the way to calculus. The idea is I need to solve for the exponent, and to do that I need to log both sides. Now here's the cool part. If you remember this is, if I rewrite this as a change of base, log base 2 of 5. So if I wrote over here, so I'm running out of space, x equals to log base 2 of 5, guess what? That's our same answer up here, except with a bunch more steps. So the identity isn't just an identity just to memorize it. It's actually a shortcut, sure. But it doesn't take away from the fact that we could go a long way around and still get to the same place, following all the rules of logs. And sometimes it's not obvious for us to use the identity. Now what if I end up with a problem that looks a little harder? If I say 6 equals to 5 to the 3x minus 4. Okay, sure. As you can tell, I need to solve for exponents, so I'm thinking automatically I'm going to use logs. So let's do it. Let's log both sides. Log 6 log 5 to the 3x minus 4. And I do this because I want to use logs like a stick to break kneecaps. And I'm going to take them to the ground. Take them to the ground. Log of 6 is equal to 3x minus 4 with log of 5 in the back. Just like in Algebra 1, we are trying to solve for x, get x alone. Let's move the log 5 to both sides. Now we have to use a calculator here, log 6 over log 5. Now you'll notice that this is going to be a decimal answer because there's no way for me to get log 6 from log 5. So I'm going to type that in my calculator. 6 log divided by 5 log equals 1.11 equals to 3x minus 4. Now since I have my calculator here, I can do some mental math, calculator math. We're going to add 4 to both sides. Now my calculator, I can just write plus 4. Watch, just plus 4. Alright, and then I'm going to end up with this number 5.11. How to get rid of the 3? Divide by 3, and you check it out. My calculator is good to go. X is equal to 1.70. Okay, and that's the most accurate without me having to reduce too early. Okay, so the question is 1.7 good enough of an answer? Well, let's go ahead and try it. If I write 6 is equal to 5, 3 to the 1.70 minus 4. Let's try it. If I say 5, and we write the exponent here, xy, I'm going to do a parentheses, 3 times 1.7 minus 4, close parentheses equals, and we are kind of close. Kind of close. That's not as close as I wish. Let's see, let's try that one more time. 5 exponent, did I make a mistake someplace? Parentheses, 3 times 1.7, close parentheses, minus 4. Oh, darn it. I should do the double parentheses. 6, darn it, let's try it again. Last time. 5 exponent, let's do a double parentheses, 3 times 1.7, close parentheses, minus 4. Oh no, yeah. Let me think. Maybe I rounded off a little too early. 6 log divided by 5 log. That's 1.1. Okay, that's a pretty big number. And then we're going to plus 4 to both sides. Then, yep. Then divide by 3 to both sides, yep. Okay, I'm going to take this number times 3 minus 4. 1.11328. Exponents, when the decimals differ by a little bit, it makes a big difference. Exponent, so 5 to the, oops. Okay, 5 exponent. Too bad I don't have it in here, the answer button. Oh yeah, I can use this one. Okay, we'll use it. Come on. Drag and drop is supported. Oh, paste it. Try and copy it and paste it, but it won't let me do it. Nah, darn it. 5xy. Nope. 5xy. 1.11328. Just I should just save time. See, that's closer because I had more decimals there. Okay. Could I have done this using our identity? Sure, you could have done this using the identity. If we had at this point, let's see where we at. We start off right here. If I had just said, let's use our identity, log. I don't know why I have an add for Botox. Base 5 of 6 is equal to 3x minus 4. That would give us our same step as right here, right? That would take us to here. So we could save a lot of time if I just remembered the identity. Now, what if this was an E problem, which is our next thing that kids get confused about? What if I write 99 equals to e to the x plus 2? Remember, e is my base, so we're going to use natural logs here. So I'll use natural log to both sides, 99 minus, or equals to log, natural log, x plus 2. And that's one of the shortcuts. Instead of using a common log, you can use natural log, you can use any log you want to save time. So natural log of 99 is equal to, in this case, the exponent goes to the front, right? X plus 2, and the natural log of e cancels out, which is what you want to realize, that the natural log and e cancel out. Natural log of 99 minus 2 is equal to x. So that's your answer from your calculator. Okay. And the last thing you guys are going to do is one more step, which is rewriting. Now this part can be a little tricky, but they want us to rewrite the logs as one log. That's what the statement's saying. Okay, so for instance, let me get to it. If I give you log base 2 of x is equal to 3, solving for our logs now. Okay, we're going to go backwards and try and get into our logs. What do logs solve for? That's my question. What do logs solve for? Logs solve for exponents, right? So logs solve for exponents. So here's what we want to say. 3 is not a regular 3. 3 is an exponent. So our next step here is log base 2 of x is equal to 3. And this is the trick. You make 3 an exponent. And you make an exponent on both sides. And what happens is the log and the exponent, remember how exponents solve for logs and logs solve for exponents? They're inverses of each other. Those automatically cancel out. X equals to 2 cubed, which is 8. Is it true that log base 2 of 8 is equal to 3? Circle of logs, 2 cubed is equal to 8. Now this might seem a little off, but let me go ahead and give you an example. Because log can seem quite difficult till you understand the basic ideas to how to deal with them. Log base 2 of x plus 5 is equal to 7. Okay, how would I solve for this? This seems like it's going to be a huge number, right? And it will be. But because 2 to the 7th power is huge, 2 times 2 times 2 times 2 times 2 times 2 times 2, 4, 8, 16, 32, 64, 128. So the logs cancel out. X plus 5 is equal to 128. Minus 5 minus 5. X is equal to 1, 2, 3. The idea here is if I'm trying to get rid of a log, we use exponents. If I want to get rid of exponents, we use logs. They're inverses of each other. And hopefully you remember this from Algebra 2, but if you don't, that's fine. What if they don't write anything? What if I write log x plus 3 equals to 2? Or what if they write natural log? What base would we have here? If you remember, if you don't write anything, that's a base 10 to both sides automatically. If you write natural log, it's going to be e to both sides. We always just copy the base, and that's our new base, because 2 was an exponent, because logs solve for exponents. So those answers are actually exponents. Those cancel out automatically. X plus 3 is equal to 10 squared. X plus 3 is equal to e squared. Answer here is e squared minus 3, and x is equal to 10 squared minus 3. So whether you have a common log or a natural log, you want to know these invisible bases are either 10 or e. And really, you just got to practice this, remember it, so that if you do ever see it on the SAT or you see it in a higher level math class, you won't freak out too much. And you remember, logs aren't that hard. You just have to remember, for instance, the opposite of multiplication is division. How long did it take you guys to remember that? I still have freshmen that don't know the opposite of multiplication, division, or addition and subtraction. I say, what's the opposite step? I don't know. So this is that next level of math. Okay, and that's it. Okay.